What do you think that? You guys aren't sure, you're allowed to talk to each other. And
Or to either of us.
looking at your computers. And then make sure to put labels also so I know what you're talking about or drawing about.
Is this a diagram? Or do I have to draw like?
That's
Oh. The water not cloud.
Okay. And then where does the raindrop go? Like it comes.
Oh, so it's like showing how many.
Okay, you have about 3 more minutes. Where's that raindrop go?
sign. Probably. In the case that this day, they do fresh. So.
I've chosen.
Alrighty. So, since we're gonna go over the water cycle anyway, just have you write your name on it, turn it into your little cubby right there, and then we'll move on. Okay. Or before you leave, make sure it gets into the.
Just in case you didn't have quite enough time to get every detail that you wanted, just to make sure that it's turned in before you leave.
Okay. So we're moving on to section 3.3, which is the cycles of matter. Anyone want to take a guess at what role plants play in the water cycle and the carbon cycle?
Plants play a role. Aspiration.
Okay.
Water evaporation leaves.
Okay. Anyone else? How do plants get carbon? Or what about photosynthesis? Okay, thank you. So learning objectives. You can write this down or not. So explain how matter flows between trophic levels among ecosystems. You guys just did food webs. And how energy flows. Now we're going to talk about water and nutrients. Explain how water cycles globally. Identify the importance of our main nutrient cycles. And explain how nutrient availability affects primary productivity. You guys done? Do you have these PowerPoints on your teams? Right. So I would take notes if I were you. So this kind of illustrates the difference between energy and the cycles of matter, where energy only flows in one direction. You have nutrient cycles and water cycles. That's a continuous loop. It goes within and between ecosystems. So unlike energy, it is used over and over again. It's never used up. And it flows through all four of your global systems.
yes, the PowerPoints are on Teams. I made a channel that says chapter 1, chapter 2, chapter 3, and there's copies of PowerPoints in there if you need to look at it some other time.
And one last thing, so all of these cycles are called altogether biogeochemical cycles. Just because they all work together, they're all cycles. So yeah. Anyone still need some time on this one? You want any more time? So the four different processes, we've already just said biogeochemical. So biological processes. Anyone have any idea what that means? So the process is conducted by living organisms. So every time you breathe, burn food, eliminate waste products, any biological process, there's nutrients flowing through that one way. Geological processes include volcanic eruptions, movement of materials above and within the earth, breakdown of rock, and the formation of rock. Those are your geological processes. Physical and chemical processes. So what I just asked you to do, the creation and formation of clouds and precipitation, the flow of running water, and even lightning. Lightning has some role in this process. And finally, human activity. So when we mine and burn fossil fuels, that moves nutrients. So clearing of land for building and farming, they burn or clear forests, and the manufacturing use of fertilizers. All of those human activities also contribute to these cycles. Anyone wonder why human activities are separate from these other three?
Pretty much like unnatural.
So, while we don't think we're doing a lot by like clearing forests or mining fossil fuels, the impact that we have on these systems is a lot bigger than any of the natural systems. Anyone need more time? Writing down your thoughts. So, let's confusing. I was confused at first, but it's just a way of showing how your element cycles affect each of your four global systems: biosphere, geosphere, hydrosphere, atmosphere. So, the main thing is that your element cycles throughout all four of your global systems, and human causes affect the biosphere and atmosphere, the hydrosphere and geosphere. Anyone have any questions about that? Okay, water cycle. Anyone want to take a guess at what all these are? So, let's start. So, water vapor. It's atmospheric water gets pushed around by the wind, go along the way. So what happens to that water eventually? Sorry, gas. Precipitation. Has to get down somehow, right? So as the water cools, it eventually becomes condensation, and it's warm enough, and there's enough of it. It eventually falls as rain, snow, hail, anything like that to the earth. Some of it will penetrate far enough to become groundwater. Yes. He's not back yet. And then any idea how it ends up in the ocean? Well, it gets there in a process called runoff. So when it rains, it will, run into streams and rivers that eventually go out to the ocean. So how does it get back up into the atmosphere? Evaporation. Yeah. So evaporation is one of them. And is there another way it can get back into the atmosphere? You said it earlier, transpiration. So there you go. Transpiration. So, if you've ever covered a plant in some plastic, not trying to kill it or anything, but then next day, maybe a few hours later, there's a bunch of little droplets on the plastic. Yes. So plants do that, and it goes back into the atmosphere. Oops. Any questions? That one? All good to go? Are you raising your hand or something? Are you guys all done writing? Okay. The nutrient cycles. Got this little sheet here. So the point is that every organism needs nutrients in order to grow and carry out life function. Nutrients go through the biogeochemical cycle. So the CO2 that these guys breathe out, carbon dioxide goes back into the atmosphere. It's just kind of showing how everything is connected. Choice of carbon cycle. So the carbon cycle is a major part of every living thing, really. You find it in your carbohydrates, lipids, proteins, nucleic acids. Anyone want to take a guess as to why nucleic acids are important? It's in our DNA. All those 4 little letters, those are called nucleic acids. Calcium carbonate makes up animal skeleton. That. It's also found in fossil fuels like coal, oil, and natural gas. And CO2. 4 things that are highlighted are what we call carbon reservoirs. So carbonate rocks, dissolved carbon dioxide, forest and fossil fuels. Anyone know what a reservoir is? Exactly. So these are 4 places where it's stored. The ocean makes up most of the earth, so that's your biggest carbon reservoir. And it's continuously being exchanged in your atmosphere, the ocean, earth. Anyone want to guess what that arrow? It's a biological process. It's plants. Word for it. Photosynthesis. So that's a biological process. So where does the second half of the arrow go? Let's do photosynthesis, and then what happens? Usually a byproduct of photosynthesis. Right. So carbon goes back up in after the plant gets thing. So what do you think is here? They just had a food web project at the very bottom. The very bottom of the food web. Okay. So what eats dead animals? Right. So plants eventually die and rot. And so over millions of years they become those fossil fuels. And then one. That's like coral add to the fossil. Geological forces can turn accumulated carbon into carbon-containing rocks or fossil fuels. That, so, any ideas why it's blue and green? It's actually highlighted. that. And what else? And water. So it's water. And this terrestrial. Both of those contribute to creating fossil fuels. That's why they're both. So, minutes. Anyone want to guess what this is? It's a geological process. It's shooting things back up into the atmosphere. Volcano. But it's geological. And then it's a growing chemical. And then human activities, we burn fossil fuels and we burn forests and so on and so forth. So when we burn fossil fuels, carbon is released back into the atmosphere, and the same with forests. So, come back to this one. So this is telling you where it enters living systems through plants and algae, through photosynthesis, and then the routes that it can take to go back into the atmosphere. Once you're done with that slide, and back up, see you have a few minutes left. So we'll continue tomorrow.